If we look next, we're going to look at the trig values of my special angles. My special angles are going to be 30 degrees, 60 degrees, and 45 degrees. They come from your rules from geometry for 30, 60, 90, which tells me my short leg is going to be opposite my 30-degree angle. The hypotenuse is going to be twice as big as that. And then the long leg, the one opposite the 30 degrees, is the square root of 3 times that, times the short leg. In a 45, 45, 90 triangle, my two sides are the same. So the hypotenuse is the square root of 2 times the side. Yes, at some point you're going to have to memorize these. But for right now, we're just going to use our chart. We're going to say the sine of 30 is 1 over 2 because it's x over 2x. The cosine of 30 is the square root of 3 over 2. And the tangent of 30 is the square root of 3 over 3. And then I just flip those around for when I'm doing 60 degrees. So the sine of 60 is the square root of 3 over 2. The cosine of 60 is 1/2. And the tangent of 60 is the square root of 3 because it's the square root of 3. Tangent of 60 is the square root of 3 over 1, which is the square root of 3. Then if we look at 45, the sine and cosine of 40 are both the square root of 2 over 2. And the tangent of 45 is 1. Now we can use that to apply to a problem. I want to use trig values, my trig functions, to find the exact value of x. So what happens here, I look at, here's my angle, which is 60 degrees. I have the hypotenuse, which is 12. And I'm trying to find the opposite, which is x. Well, if I look at that opposite hypotenuse, I'm going to use cosine. So I'm going to say, oh, the cosine of 60 degrees equals the opposite. Sorry, that's not cosine, that's sine, isn't it? Sorry about that. Sine is opposite. So the sine of 60 degrees is the opposite, which is x, over my hypotenuse, which is 12. Well, if I look at my chart here, the sine of 60 degrees, let's highlight that here. The sine of 60 degrees is the square root of 3 over 2. So what I'm going to say then, instead of saying the sine of 60 degrees, I'm going to say, oh, the square root of 3 over 2 equals x over 12. Well, to solve for x, I multiply both sides by 12. And then 2 goes into 12 6 times. So x is 6 times the square root of 3. That's using your trig functions. Now, if I look at example 4, here's an application. We won't necessarily use our table, we'll use our calculator. It says to calculate the height of a building, Joel walked 200 feet from the base of the building and used an inclinometer to measure the angle from his eyes to the top of the building. If his eye level is 6 feet, what's the distance from the top of the building to Joel's eyes? Well, what happens here, we want the distance from the top of the building to Joel's eyes. It doesn't matter how tall Joel is. We're going to find D. I look at this problem. Here's my 76 degrees. I'm going to use my 76 degrees. D is my opposite. And 200 is my adjacent, so I'm going to use tangent. I'm going to say, oh, the tangent of 76 degrees then is D, which is the opposite, over the adjacent, which is 200. So in other words, I multiply both sides by 200, and D is 200 times the tangent of 76 degrees. And when I round that, it doesn't tell me what to round it to. I'm going to round it to the nearest foot because everything I have is to the nearest foot. So if I use my calculator now, I'm just going to take 200, make sure you're in degrees. You can see that because you have the DEG right there. So I'm going to say 200 times the tangent of 76 degrees, and that's 802, I'll say about. So that's about 802 feet. And that's what we'll have to do with that one.